Okay, I just want to take a moment to go through the notes from today. Um, this is just basically a simple way of looking at atoms and the components that make them up and how the relationships to each other all can relate. In the center of Matterville, there is a place called the Nucleus Arcade, where two members of the Adams family like to hang out. Perky Patty Proton, like her sisters, is quite large with a huge smile and eyes that sparkle. Patty is always happy and has a very positive personality. So in that very first box, we're going to label it Patty Proton. We're going to go ahead and put big smiles, plus signs for eyes because she's a positive particle. Her description is she is positive. And her favorite activity is hanging out in the nucleus arcade because the protons are one part that's in the nucleus. Now, along with Patty is nerdy Nelda Neutron. She's large like Patty, but she has a boring flat mouth and eyes with zero expression. Her family is very apathetic and neutral about everything. Patty, Nelda, and their sisters spend all their time at the arcade. So we're drawing Nelda Neutron. We use zeros for eyes because there is no charge. It's a neutral particle. Description is just that. It is neutral. And like Patty, Nelda and Patty hang out in the nucleus arcade because the protons and neutrons are the particles that are inside the nucleus that make up the atomic mass of an atom. Now, around the nucleus arcade, you will find a series of roadways that are used by another member of the Adams family, Enraged Elliot Electron. Elliot races madly around the arcade on his bright red chrome-plated Harley Davidson. He rides so fast that no one can be sure where he is at any one time. Elliot is much smaller than Patty and Nelda, and he is always angry because these bigger relatives will not let him in the arcade. He has a frown on his face, eyes that are squinted with anger, and a very negative attitude. So when we draw Elliot, we draw negative signs for eyes, and we can make him facing down because he is a negative kind of guy. Frowny face, again, negative, and he does not hang out in the nucleus. He races around the nucleus in the electron cloud. Okay. Now we talk about the structure of an atom. The first energy street that can hold only 2 electrons. The second energy street, called the energy freeway, can hold 8 brothers. The third energy street, called the energy superhighway, can hold 18 of the brothers. What they're talking about here is when we talk about electron clouds, electron shells, rings, orbits, whatever you want to call it, to a certain point, they can only hold so many electrons before they are considered full, and then they have to move on to the next ring, cloud, shell, or orbit. So here's the nucleus where our protons and neutrons exist. Our very first cloud or shell or ring or orbit can only hold 2 electrons. So anything that has more than 2 electrons, the third electron would have to go on to the next ring. So only 2 electrons can fit on that first shell. When we go out to the second shell, ring, orbit, cloud, energy level, this second one can hold up to 8 electrons. And then finally, this outer level and every level past them can hold up to 18 electrons. Nothing that we're doing today requires us to get that high in numbers, but just so you know, we have the nucleus. The first shell, ring, orbit can hold 2 electrons. The second ring, shell, cloud, orbit energy level can hold 8 electrons. And the ones past that can hold up to 18. Okay. I'm going to go ahead and skip the video and the lyrics. You're welcome to watch those on your own leisure. But they also talks about what we kind of called ions, but in class today. But the morale of Matterville is stable as long as each electron brother is balanced out by one positive proton sister. The number of residents in Matterville depends on the proton and neutron families. So when we look at an atom, if it is balanced and happy, I guess you could call it, it would have an equal number of protons and electrons, positive protons, negative electrons. But what would happen to the morale of Matterville if one Elliot electron was kidnapped? Well, if we take one Elliot, a white van comes, grabs Elliot, throws him in, off they go. Now I have 1, 2, 3, 4 positive particles and 1, 2, 3 negative particles. Because I have more positive than negative particles, this becomes a positive ion, also known as a cation. Now, let's say they return Elliot, but return to a different town, or a new Elliot moves in. Again, it has to be balanced. If I have 1, 2, 3, 4 positive Patty protons, but 1, 2, 3, 4, 5 negative Elliott electrons, then what we have is too many negatives, which makes the atom negative, or a negative ion, or also known as an anion. Now, when we fill out an electron box, and I'll go through this, I'll make a separate video on the practice sheet myself so we can use it. But whenever we read an element box, there's some information we always get. And you're going to have to label this information on your, it's going to be on your worksheet, but not on your notes. So, the first one is the atomic number. The atomic number is the number of protons. Now, here again, they say atomic number equals protons or electrons. But don't forget, we have things like anions and cations. An element can lose or gain electrons without changing what it is. However, if you change the number of protons, you are changing what that element is. I think if you add a proton to this, it would become 9, which is fluorine. If you took a proton away, it would become 7, which is nitrogen. So the atomic number is the number of protons. It really is what makes an element what it is. In an element box, you also have a symbol. A symbol is just a letter that represents the element name itself. 95% of the time, they do make sense. O for oxygen and so forth. There are times that there are carryovers for elements that no longer go by a previous name. Like sodium used to be called natrium, so it's Na. So lead used to be called plumbum, which is Pb. But whatever letters you hear, that's called the symbol. It's just the letters that represent the element itself. Next, I have the name of the element. And finally, I have the atomic mass of the element, which is the number of protons and neutrons in the atom, and it's usually an average. Remember, the atomic mass equals the number of protons and neutrons. Which leads us to our practice sheet. Okay, so now you can use the back of your textbook. Any periodic table would work. I'm going to go ahead. I think this is recording. And fill this out, although I'm missing my little icons here. All right, I will make a separate video for the icons here on Cami or on just videotape it myself to show you how we're going to fill this out. So if you have no questions in the notes for Adam's Family, that should go ahead and take care of it. If you have any questions, please feel free to reach out, contact me. Well, there's what I'm looking for. Will this stay here if I move it? Let's see if I reload again. Aha, okay. I lied. I'm going to go and try this while I have the same thing open. All right, so I'm going to change to a pen because that's going to be a little easier. So let's change to black ink so you can read it. With each element box, there's a piece or maybe a couple pieces missing, but there's some general information that we can write down as well. The number on the top of our box is our atomic number. So in this case, and I apologize for my writing, is atomic number 8. Well, again, what we know is that whatever the number is, that is also the number of protons. That's where we get it from. Okay, if we have 8 protons, if we have atomic number 8 protons, that means we have 8 electrons because we are dealing with positive particles. And I do apologize, my writing's going to be really messy on this. I'll try and do better. Up here, we would write our name, which is oxygen. Yeah, I know. I'll do another video of this as well because yikes. It's like I'm writing on a car drive or something. All right. Atomic mass is going to be always this number here. Wow. That's a 15. We're just going to go ahead and carry it to the 0.9. And the last thing we need to find is the number of neutrons. To find the number of neutrons, we're going to take the number of the mass. Remember, because the mass is protons and neutrons. So if I take the mass, I subtract the if I subtract the protons, what's left are my neutrons. So I get 7.9. All right, let's try a different one. For zinc, this is number 30. Okay, so abbreviation or symbol is Zn. The number is given to me. It's atomic number, so it's atomic number 30. Wow, okay. Sorry about that. It's hard to write on this. Remember, if I have 30 as my atomic number, that's also my number of protons, which is also my number of electrons. So if you really wanted to, you could go through and fill out the sheet for these three columns, for these three rows, all the way down the sheet. Because these three numbers are always going to be the same. Atomic number, number of protons, and number of electrons are always going to be the same. For atomic mass, I get it from right here, which is 65.39. And as I said before, to find the number of neutrons, take your mass, subtract the protons. What's left is neutrons. In this case, I get 35.39. Wow. It's bad writing. All right, we'll do one more as an example, then I'll do the rest on a different format just to kind of make sure you understand and hopefully make it a little clearer for you. Atomic number, again, always the number on top, so atomic number is 3. Wow, horrible 3. If it's atomic number 3, that means it is 3 protons. If it's 3 protons, that means there's 3 electrons. This is lithium. I can look that up on my periodic table in my book or online. Yeah. This is why I don't use Cami. I can't write with this stuff very well. So the atomic mass is down here, which is 6.94. If I subtract the mass minus my protons, what I have left, the 3.94, is the mass of the number of neutrons that I have. And again, it's an average. That's why it's a decimal. All right. So again, with silicon, boron, and bromine, you can do the same thing. I'll have an answer key posted tomorrow. They will also I'll have a handwritten copy. I'll do one on paper so you can see how that kind of works, so maybe a little more efficiently. But if you have any more questions or any questions about this, please feel free to reach out. But that is the notes and the general instruction on how to start and do the homework.